All right, let's pull back the curtain on one of the most fundamental processes in all of modern tech, how an AI really learns. It's a pretty fascinating journey, going from a totally blank slate to an incredibly powerful tool. So let's just dive right in. So you gotta wonder, right? How does an AI go from zero to hero? From knowing absolutely nothing to suddenly being able to draft an email, create a stunning image, or even help discover new medicines? Well, the whole process really boils down to one key idea.
That process, it's called training. And honestly, the best way to think about it is to picture an AI model as a student who's got a massive exam coming up. Its textbook is this gigantic dataset, and its only job is to learn the patterns inside so it can make the best guesses possible.
Okay, so if you're this AI student, how would you start studying? Well, one way, and it seems pretty logical at first, is to just take it one fact at a time. Like looking at a single flashcard, learning it, and then moving on to the next one.
And the process here is super simple. Step 1, the model looks at one thing. Let's say a picture of a cat. Step 2, it makes a guess. Maybe it says, dog. Step 3, it sees the mistake. Whoops, that's a cat. And here's the kicker. Step 4, it immediately changes its entire understanding based on that single mistake. Then it just repeats the whole thing with the very next picture.
So this whole one-by-one method actually has a pretty fancy name in the AI world. It's called stochastic gradient descent, or SGD for short. But all you really need to remember is its core idea. One piece of data, one immediate update.
But, and this is a big but, there's a huge problem with this approach, a really critical flaw. It makes our AI student, well, kind of freak out and overreact to everything it sees.
Okay, so look at this. Ideally, learning should be a nice, smooth curve heading steadily towards the right answer, right? But with this one-by-one method, you get this chaotic, zigzagging mess. It's like a student who gets one flashcard wrong and then completely panics, throwing out everything they thought they knew. It's just so inefficient.
And this really gets to the heart of the problem. Because it reacts to every single little thing, the learning process becomes, and this is a great quote, very, very wild. Think about it. What happens if the AI sees just one really weird, misleading piece of data, an outlier? Boom, it gets thrown completely off track. Its entire understanding can swing in a totally wrong direction because of just one bad example. So let's just recap the flaws here. This one-by-one method, it's super sensitive to weird data. The updates are constant, yeah, but they're chaotic. And when you're dealing with the huge data sets that modern AIs use, it's just way too unstable and unpredictable. Clearly, there's got to be a better way to study.
And of course, there is. The secret isn't just about studying faster, it's about studying smarter. So instead of looking at just one flashcard at a time, what if our AI student looked at a small stack of them all at once? This idea is called a mini batch. It's simple, really. Instead of one data point, the model grabs a small, manageable group, maybe 20 examples, maybe 50. And the key is, it looks at that entire group together before it decides to change its mind about anything. So, look at how the process changes now. It's still looking at data, still making guesses. But the game changer is step 3. Instead of having that knee-jerk reaction to one error, it calculates the average error across the whole batch, and only then does it make one single, much more thoughtful, much more informed update. This chart just says it all, doesn't it? If you have 100 examples, the old way means 100 separate, frantic updates. But look at this. If you group them into batches of 10, you only need to make 10 updates. 10! And each of those is way more stable and considered. That's a massive difference. So you might be asking, why is this one little change from one-by-one to batches such a big deal? Why is this the standard for pretty much all modern AI?
Well, it all comes down to this. When you learn in batches, the path to getting smarter is just smoother and more stable. And remember that outlier problem? That one weird piece of data? With batches, its impact gets totally watered down, averaged out with everything else. It can't throw the whole system off course anymore. You end up with something that's way more efficient and, frankly, just more reliable. And then you have to think about scale. We're talking about modern AI models being trained on data with literally trillions of data points. Trillions! At that point, a one-by-one method isn't just slow, it's completely impossible. Learning in batches isn't just a clever trick, it's an absolute necessity. So,
If there's one thing to take away from all this, it's this simple idea: learning from the average of a group is just way more stable and efficient than overreacting to every single piece of information you see. It's really about seeing the big picture, the whole forest, instead of getting lost and confused by one weird-looking tree.
And that kind of leaves us with a final interesting thought, doesn't it? If the secret to making AI smarter and more stable is teaching it to learn from the average of many different points of view instead of overreacting to any single one, well, what does that say about how we should probably approach learning too?